By now you know that numbers could be prime numbers or composite numbers. Prime numbers have only two factors, the number 1 and itself. On the other hand, a composite number has more than two factors. An important property of composite numbers is that all composite numbers can be made by multiplying together a set of prime numbers. Prime factorization of a number means finding the unique set of prime numbers that, when multiplied together, equal that number. Another way to describe it is the process of representing a composite number as a set of prime numbers multiplied together is called prime factorization. You will need to know how to do prime factorization in order to find the least common multiple and the greatest common factor of numbers. Let's look at some composite numbers written using the prime factors only. So up here I have a few examples of composite numbers and their prime factorization. So the only factors that I've written for them are their prime factors. So 35, for example, 34, for example, equals 2 times 17. Both 2 and 17 are prime numbers. 39 equals 3 times 13. 3 and 13 are both prime numbers. 77 equals 7 times 11. And then we can see on this 60, I've only written out the factors of 60 that are prime numbers. So I can look at 60 as 2 times 2 times 3 times 5. If I multiply all those numbers together, I will get the answer of 60. So we can see that each of these numbers has the primes 2, 3, 5, 7, 11, 13, 17 prime numbers as their factors. Let's look at an example where we are asked to find the prime factorization of a number. So this problem says to find the prime factorization of 140. And so what we're going to do is work on finding all the prime numbers that multiply together to give us the number 140. An easy method for finding the prime factorization of a number is using the pyramid shape. So we're going to start with the number 140 as the peak of a pyramid. So I'm going to do a little lines in the both directions to start to break down 140 into its prime factorization. So to start, we need to find one prime factor of 140. We start with our smallest prime numbers and see if the number that we're working on is divisible by those prime numbers. So I can see, first of all, in my mind, I have that my smallest prime number is 2. And I can see that 140, since it ends in a 0, is an even number, and so it will be divisible by 2. So I break that 140 down into its factors of 2 and 70. Now, since 2 is a prime number, this is where we will keep this 2 here, and we'll move on then to finding more prime factorizations, or more primes that are factors of 70. So we leave our 2 here and we work our way down to the next level of our pyramid. So now I'm going to work on finding prime factors of 70. So again, 70 is also an even number, and so I know that it will be divisible by my smallest prime number, which is 2. So I take my 70, divide by 2, equals 35. So now I can break down the 70 to a prime number 2 and 35 here. So far I've got 2 as a prime, so I leave that. I have this 2 as a prime, so I leave that. And now I need to work on finding the prime factors, the smallest prime factor of 35. So I'm going to work on my next level of my pyramid. I keep my 2, and now I want to break 35 down and see which prime numbers it's divisible by. So 35 is not divisible by 3. 3 doesn't divide into 35 evenly. I know it doesn't divide by 2 evenly either because 35 is not an even number. So what I'm doing here when I think about this 35 is I want to find the smallest prime number that is a factor of 35. The smallest prime number, as we've talked about before, is 2, but I can rule out 2 as a factor of 35 because 35 is not even. So then I move to my next prime number, which is 3. The next smallest prime number is 3. And I ask myself, is 35 divisible by 3? No, 3 does not divide evenly into 35. So I go to my next prime number, working my way up. My next prime number is the number 5. Is 35 divisible by 5? Yes. 5 times 7 equals 35. So I can break this 35 down into 5 times 7. Now that all the numbers in my row here are all prime numbers, I can stop. If this number was still a composite number, I would need to do another level of the pyramid. But I can stop at the point in which I have all prime numbers, 2, 2, 5, and 7. If I multiplied together 2 times 5 times 7, my answer is 140. You need to practice doing these prime factorization problems a lot to become very familiar with them, and then they become simpler and simpler the more practice that you get.